Okay, today we're going to do Module 1, Lesson 3, and it's on scientific notation. So we're going to practice writing numbers from standard form to scientific notation, and then going from scientific notation to standard form. And we've kind of scratched the surface on this the last couple of days. And so this is what we're going to do today. So the first thing is where we're going to make a statement about what scientific notation is. So scientific notation can be multiplied by a power of 10. And we've been talking about writing numbers to the power of 10. So it could be multiplied times the power of 10. And we're going to express it in the general expression of A. A stands for any number times 10 to a power. A stands for any number times 10 to a power. And the absolute value, remember the absolute value of a number is, if negative 9 is my number, the absolute value of negative 9 is 9. So when we write numbers in scientific notation, we take into account the absolute value also. And it must be at least 1, but less than 10, because we've been practicing writing numbers times the power of 10 with a single digit, and that's why it is greater than 1 or greater, and less than 10, because those are only our single digit numbers. So that's mean it's going to be between 1 and 9, or for absolute values between negative 1 and negative 9. Now let's talk about some pieces of scientific notation. The first piece we have is the first factor, and then we have the order of magnitude. So highlight, circle, underline those words. And when we look at this expression, 8.86 times 10 to the 6, our first factor is 8.6, and our order of magnitude is 6. It is just the exponent. So our first factor is 8.86, and our order of magnitude is 6. And then we're going to look at examples of that. So we want to look at these examples and say, yes, it has a single digit number between 1 and 9 times 10 to a power. So let's see. And these would be the answers for these. And the reason these are not examples is because they all have a first factor that is not greater than 1 or greater, or less than 10. Now we're going to write these in standard form. Remember, we are multiplying times the power of 10. So 3, let me go back to my pen. 3 times the power of 10 twice, or 3 times 100 would be 300. Here we would be 4.8 times 10 3 times, or 4.8 times 1,000. Means we have 3 place values that we would move our decimal. So we would move that decimal 1 place value, 2 place values, 3 place values. So 4,800 would be our answer. Then this one, we would have 6.75 times 6 tens. 1, 2, 3, 4, 5, 6. Or 6.75 times a million. So we would move our decimal place 6 place values. So our answer would be 6,750,000. Because remember, we are multiplying times the power of 10. Multiplying times the power of 10. And then let's look at number 12. Number 12 says, Logan writes the number 6.7 times 10 to the third in standard form. He writes 67,000 because 10 to the third represents thousands. Do you agree with Logan? So do you agree or disagree with Logan? I disagree. I disagree because 6.7 times 10 to the third is 6.7 thousands, not 67,000. So the correct answer is 6,700. And we want to use as much math language as we can when we talk about these. Okay, let's write 2,000 in scientific notation. Oh, did I move pages? 2,000 in scientific notation. So I'm going to look at my first single digit, which would be 2, times 10. And how many tens till I get to 2? There's 1 10, 2 tens, 3 tens, 4 tens, 5 tens. So 2 times 10 to the 5th power. We're going to do the same thing for these. Remember, I want to place my decimal where I have a digit that is between 1 and 9. So my decimal is going to be here, 4.75. And how many tens do I have? 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7th. Again, here, my decimal is going to go after the place. And I'm going to keep all the digits until I get to zeros, until I get to just zeros. All those digits need to stay. And I have 1, 2, 3, 4, 5 tens times 10 to the 5th. Here, again, I want my decimal to be where I have one digit between 1 and 9. And again, I am keeping all of these numbers until I get to just zeros. And I have 1, 2, 3, 4, 5, 6 tens. So times 10 to the 6. Now this one, 36,360. Sometimes it's easier to write it out to see it. So 36,360. I want my decimal to be where I have one digit between 1 and 9. And I would have 1, 2, 3, 4. So 3.6360 times 10 to the 4th. I'm going to also give you a anchor chart. So we're going to say scientific notation is written A times 10 to a power. This A is our first factor. It is between 1 and 9, or the absolute value of -1 to -9. So we're going to highlight those all one color because that all goes together. Then next we have a power of 10. And we're going to highlight those all one color because those all go together. And then we have an order of magnitude. Or an exponent. And we're going to highlight those another color because that all goes together. You could put this in the back of your notebook with your anchor charts for scientific notation.